Got to give the people, move this heater out the way. Give the people what they want. Bass, I'm right here, talking about roots and fractional exponents. All right, we're gonna try to make some sense out of these. It's easy, quick ways to remember it, but I wanna make sure that hopefully it makes some kind of sense as to what we are doing. So, let's start off with some examples. So I'm gonna take the square root. If I have a square root, it's really invisible here, invisible too. What's the square root of 25? Well, you know that that is 5. Okay? All right, so if I take the square root of 25 times the square root of 25, I'm really saying 5 times 5. Hopefully that makes sense, right? And 5 times 5 is 25. So the square root of 25 times the square root of 25 is 25. So notice, if we take the root, square root of 25 multiplied by itself twice, right? Here's the 2. So if we take this, we multiply it by itself twice, we get 25, which is this number that's in the inside. All right? Let's just check real quick and see if that works in the other case. Let's take the cubed root now of 8. Go ahead and tell me, what is the cubed root of 8? You should have been able to calculate that that is 2. Right? So if I take the cubed root of 8 times the cubed root of 8 times the cubed root of 8, right? What I'm really taking is 2 times 2 times 2, which happens to equal 8. So the cubed root of 8 times the cubed root of 8 times the cubed root of 8 is 8. So again, if I take now the cubed root, what can you see? Yes. The cubed root multiplied by itself now 3 times, we get 8, which is what's inside of here. So this is just some background of what we need to get. So now we're going to take what we learned here and build from it. So I want to show these roots, right? And I'm going to do it with the cubed root of 25. I'm going to show these roots, but now I'm going to show how I can show the same thing in an exponential form. So let's take this now, showing roots in exponent form. Okay? So let's take what we already have. We already know that, let's take the square root of 25. I want some number times itself that's going to equal 25. Just like we did right here. Some number times itself equals 25. 25 is 25 to the first power. But now I'm not going to show us the square root of 25 times the square root of 25. I'm going to show it in a different way. I'm going to show it using exponents. So I need 25 to some power times 25 to some other power. It's going to equal 25. Well, my only option here is to have the power of 1/2 and 1/2. Well, why is that? Well, let's go back and put a star and write remember. Right? If I took x to the second times x to the third, that means x to the 2 plus 3, right? Which equals x to the 5th. So, in this case, 25 to the 1/2 times 25 to the 1/2 is 25, to the 1/2 plus 1/2. which equals 25 to the first power. Please make sure you're taking a moment to let this sink in and make sense, right? So if I take some number times itself, and I want to get 25, which is 25 to the first, I have to take 25 to the 1/2 power times 25 to the other 1/2 power. Because a half, 25 to the 1/2 times 25 to the 1/2 would actually be the same as 25 to the first, because a half plus a half is 1. Okay? So that means, well, if 25 to the 1/2 times 25 to the 1/2 is 25, and the square root of 25 times the square root of 25 is 25, that 25 to the 1/2 has to be the same thing as the square root of 25. Those are the same. That is a humongous key. All right? Again, take a second, pause, look back to that. Go through it, listen to it again. Please make sure that makes sense. All right? We're going to do another round of that. Notice I'm going to move a little faster. So let's say we're trying to see, well, what is the cubed root of 8 equal as a fractional exponent? Right? Well, again, we remember if we want to get 8 or 8 to the first power, I need some number times itself 3 times now to equal 8 or 8 to the first power. Okay? Well, now I'm thinking, well, what plus what equals 1, right? 1/3 plus 1/3 plus 1/3 equals 1, in the same way that the cubed root of 8 times the cubed root of 8 times the cubed root of 8 equals 8, or 8 to the first power, right? Because again, I can see here, right? So the cubed root of 8 is the same as 8 to the 1/3 power. And again, remember, if I have 8 to the 1/3 times 8 to the 1/3 times 8 to the 1/3, it's 1/3 plus 1/3 plus 1/3, which is 3/3, which is 8 to the first power. All right? So 8 to the 1/3 power is the same as the cubed root of 8. 8 to the 1/3 power is the same as the cubed root of 8. I can do more and more of these. I'm just going to do these 2 right now. So this is moving in one direction. My whole point in one direction. My whole point is I want you to see why these work. We'll be talking about them in class, but hopefully this makes some sense. But now let's look at moving the other direction. Okay? Let's look at moving from, let's move now, let's convert from exponential form to root. I think you can see this. Exponential form to root form. Okay? And we're going to kind of build it the same way, but we're going to look at it slightly differently. Okay? Let's say we had a number line, right? Here's a nice number line. So you draw this number line. Here is 3 to the 0 power, which is 1. We know that, right? Here is 3 to the first power, which is 3. We should be good on that one, right? Well, we want to know what's 3 to the 1/2 power going to be. So let's figure this out. Well, I know to move from 3 to the 0 to 3 to the first, and all this space I multiply by 3. I think we can all agree to that. So for this space here and this space here, this times times this, when I multiply them together, that should be the same as multiplying by 3. Well, what's the only number, and again, I can build this. Some number times itself equals 3. Well, that's the square root of 3. So this is square root of 3, and this is the square root of 3. So 3 to the 1/2 power is I need 2 of these square roots of 3, because when I multiply those together, if I was going to go 3 to the 0, all the way to 3 to the first, I have to multiply by 3. So if I cut that in half, I take 3 times the square root of 3 times the square root of 3 is the same as this whole amount of space. Okay? So square root of 3 is 3 to the 1/2. Square root of 3 is 3 to the 1/2. Again, we're moving in both directions. But let's look at this now if we're not breaking it into the 1/2s. Let's look at it a different way. Or let's look at another version of it, I should say, not a different way. Let's say we had, okay, so I'm going to write a similar number line. Here's 3 to the first power. Here's 3 to the 0 power. 3 to the first power is 1. Excuse me, 3 to the 0 power is 1. 3 to the first power is 3. But now I'm trying to figure out, well, that's what's 3 to the 1/2. I want to know, well, what's 3 to the 1/4? Right? These are all 1/4 powers. Or actually, I guess I should keep it like this. I want to know, well, what does 3 to the 1/4 power mean? Okay? So that means I have 4 pieces that I ultimately have to multiply together to get times 3. 1 times 3 gets me 3. So for this whole part right here, this whole part, I got to find the same numbers that I can multiply 4 times to get times 3. Well, I now need the 4th root of 3. Right? I need a 4th root of 3. I need a 4th root of 3. And I need a 4th root of 3. Because if I take the 4th root of 3 and multiply it by itself 4 times, I ultimately get 3. This is going back to what we just did in the very beginning. Right? 4th root of 3 times the 4th root of 3 times the 4th root of 3 times the 4th root of 3 equals 3. This, and this equals 3. So 3 to the 1/4 is the same as the 4th root of 3. Right? This is probably new for most people. It took me a while to even figure out how to explain it. I was talking to Mr. Tillis and Ms. Helft, and we came up with these different ways. We want you to see the ideas behind it. Okay? Now, I mean, I'm sure you guys can figure out and make up shortcuts, but if you get stuck, you should come back to the ideas, the models that show where all these pieces came from. We'll be using this in class. We'll be working on it more Friday, which is not tomorrow, but it's a couple days from now. All right, who do I owe a shout out to? Shout out to Last Time Got Killed. Shout out to, oh snap, was it Brandon? Shout out to Brandon, B Dizzle, and Luis, the Big Izel. I gotta get somebody else asked me for a shout out. I can't remember, so I guess people will just have to keep asking me for shout outs. Luis, Brandon, got you guys. Hold it down. Have a good one.